Hello YouTube, and welcome back. Hang on. Oops, sorry about that interruption. Today what we're going to do is catch up on a screencast of a project I made up, rock, paper, scissors game, to introduce for loops or while loops, looping, iteration in general. Now, if you recall, we had a C5X0 where we did rock, paper, scissors game. We're going to do lizard spot, but it was too long. In processing, let processing do the looping, and otherwise we're just using processing in standard Java. No graphics, no animation, none of that stuff. Now we're going to go into the Ubuntu desktop using our CS50.io IDE and see if we can make our own while loop take care of this game. Okay, so here we go. All right, I just started a brand new account with CS50 because my other one was getting all glitchy. So they were merging my free account, my new, whatever. Don't worry about it. But here we go. So what I'm going to do, I'm going to create a new terminal. I'm going to make a directory for chapter 6, which is iterations. Alrighty, and I'm going to cd chapter 6. Then I'm going to make a directory for C6X0 before lab 6 from the textbook. I'm just making this up. And let's cd that. Yeah, chapter 6. Exercise 0. It's actually Lab 6, Chapter 7, because the textbook has an extra graphics chapter number 5, so that messes up everything. And there's nothing here. Okay, and there's the directory structure. There's nothing there either. Okay, good. Okay. So, let's make a file. This is going to be RPS.tester.java. Okay, so let's start with some comments. Let's see, RPS.tester.java, your name and the date, and we did this a while ago, but let's say it's 2018 January 24th. And while we're at it, why don't we do a file save, RPS.tester.java. Let's make sure it's in here. And there it is, color-coded. And is it really there? It is. Okay, I never know if I'm doing that right. Okay, so that's your header comment. Okay. Can I make this a little bit bigger? View, font size. I wouldn't do Control Shift plus because it increases the window size too and messes everything up. So I'm just going to try and do this a few times so you can see what I'm doing. Is that good enough? That's probably good enough, right? Okay, one more. There you go, okay. And so purpose. Why isn't it typing? Purpose. Purpose. We're going to do play a game of rock, paper, scissors using a while loop to simulate multiple rounds. Okay. So play a game of rock, paper, scissors. This time we're going to use our own while loop. And we use a while loop when we don't know how many times the loop is going to repeat, or for loop if we know how many times you're going to count how many times the loop goes, to simulate multiple rounds. Okay, perfect. Alright. Required files will be the tester, or the main class. And RPS.java, the derived class. And whoops, what happened to my queue? Okay, whoops. Okay, translator phase, nothing special here, just Java see it. And interpreter phase, just Java it. The input is going to be using scanner. We can use arg0 input for input or scanner for input because it's all text-based in cs50.io IDE. And that's that. Okay, so let's do the class public, class RPS tester. Okay, good. Then public static void main string array args, even though we're not using that for input, that's fine. Okay, so now I usually start by constructing an object that we're testing, like the RPS class. We're testing an RPS object, right? But first, let's figure out the input. Okay, so let's see. How about let's construct a scanner object. Which is a wrapper class that enhances the input class system.in. Alrighty. And we're just going to prompt the user for input, system.out.print. Let's see, let's make it a print so the input stays in one line. Make a move. Let's hint that it's an R, a P, or an S. Or X to exit. So we'll have a sentinel loop. The loop will look for X and will stop if it sees the X, right? Maybe a little space here. And then it'll wait here for you to type in some input, and then we'll capture it. String. How about we call that person move equals input dot next. And we figured out in class that we would want to put a to lowercase here because this is a string object, and so the to lowercase method is available. And so even if they put in a capital R, we don't have to test for it. We'll just test for lowercase r. All right, so there's the user input. How about the computer? Let's see. How about this? Okay, let's go straight to the while loop. While something is true, keep on going, right? So the loop invariant is what? As long as someone doesn't enter an X, or as long as they enter an RP or an S, right? So as long as it's not true that person move dot equals, right? We need the equals method from the supercosmic object class. It's overridden in the string class that compares the contents of the instance fields of these two objects. They're string objects. The string X. All right, so let's close the equals. Let's close the while. Okay, so the loop invariant, in other words, when the loop is operating, what's true is that the user enters an RP or an S. The X would stop it, so that we're not looping in that case. So now here, why don't we have the computer choice be randomly generated? How about this? Computer choice, not computer move will be a string. Computer choice is going to be an int, all right? A randomly generated int from 0 to 2. So how are we going to do that? Well, let's see. Equals generator dot how do we do this? Next int 3. So that gives me 3 randomly chosen integers from 3 counting from 0, so 0, 1, and 2. Okay, and then we need some if statements. Okay, so this is the if statements from Lab 5. If the computer choice is 0, let's say that's a rock. If computer choice is 1, let's say computer move is paper, and like that. Okay, so here we go. If computer choice, now don't forget we have to import scanner. We have to import random for this to work. But here we go, and we have to construct a generator as a random object, right? So. All right, computer choice. If computer choice equals 0, then let's say that computer move is the string rock. Okay, there you go. Make it a double quotes. Okay, so why don't we do that? Why don't we import some stuff? Let's see, this will be the main class, and this will be the imported libraries or imported classes in Java. So how about import java.util.scanner? And import, I guess we could use the math class and not import anything for a random generator. How about, but let's use this java.util.random library. Oops, there you go. And let's construct a random object generator, what happened to my R, equals a new random object. And that's a random constructor. There you go. So a couple more if statements. If computer choice, I don't know this thing. If computer choice is 1, let's make that the integer 1, let's make that the string P for paper. And again, if it's a 2, an integer 2, let's make it a string S for scissors. Right, okay, perfect. And is that the whole tester? I guess that is for now. Now let's just test this much, okay? Now also for the loop to continue, we have to ask the user if they want to continue or not, right? So guess what? This same prompt here goes inside the loop. Okay, so let's do this. So it's a pre-test loop. While loops are pre-test loops, in that you have to prime it. You have to have at least one input available to test before you start. Okay, so, but we have to test here what the user wants to do. So they can hit an X and that'll stop the whole thing. Now for fun, what if we just print out what the moves are right now? Now notice I didn't construct, did I construct an RPS object? I didn't, right? Okay, so let's do that in a minute, and we'll pass that to RPS and let RPS class decide who wins. Okay, that's it. So each RPS object will be one round of the game. It will just compare the two moves, the computer move and the person move or human move. Okay, so right here, just do a print line. Oops, print line, and let's say person move equals plus person move. Okay, we don't have any other objects here, just the strings, but real soon we're going to have an RPS object to compare these values. Okay, and then another print line for the computer move. And how about a blank print line? Whoops. Just separate that from prompting the user for more input. Okay, so notice this does not use RPS yet, so this we can just test that this much works, that the user can input an ARP and a P, an S, or an X. And X will stop everything, and the computer will also pick a move, and we can print all that stuff out. Okay, let's just test this much. Okay, so save it. Okay, and then go to the shell. Oops. There you go. Let's Java see it. Let's see where we messed up. And what did I do? Oh, I didn't declare this. Oh, I have to declare computer move. Whoopsie. So, let's just declare that up here somewhere. Doesn't matter where, not really. So this is before we use it. So how about string person move? don't know if I have to initialize it to an empty string or something. It's a string computer move. Let's save that, Control S. Let's go over here and Java see it. Still doesn't see it. What happened? Oh, I declared it in multiple spots. I only have to declare it once in the whole program, in the whole main class, right? So where did I do that? Ah, here is where I did it. And here I didn't do it. But you know what? So let's just declare it up here and get rid of this one. There's nowhere else I'm declaring it, right? Alright, so this initializes it, and this initializes it, this declares it. That should do it. Control S. Now what? What, not 48? 48? Why did I do? Oh, because I cut and pasted that. Silly teacher. Alright, but there looked like there's a bunch of other. Oh, computer choice. You know, computer choice is an int. Isn't it? I better put that in here somewhere too. How about int computer choice? Alright, I think all the variables are declared at least. Let's try that again. What do I do now? May not have been initialized, really? I thought it was. In line 45. Line 45. Computer move. Oh, right. Oh boy. Yeah, that's a warning. Did it actually do anything though? It didn't actually run. That's an error. Alright, so to avoid that error, let's initialize computer move. Let's initialize computer move to an empty string. Good. Okay, let's run it. Get rid of the .java and the C in Java C. Alright, so let's say I do rock. So a person move is rock, computer move is paper, and make a move. Okay, let's do rock again. Let's do rock again. Okay, now it's rock. That's a tie. By the way, rock, paper, paper wins. So the computer won twice, and then there was a tie. Let's do another rock. And that's the computer wins. Computer wins. Are we ever going to get S? Computer wins. Computer wins. Where's S? There's S. And rock smashes scissors, so person wins. Okay, that seems to be working. And then how about paper? Okay, paper and scissors. Scissors wins, so computer wins. And paper, rock, paper covers rock, so paper wins. And do we get a tie? Paper, paper, it would do. Okay, and scissors. Person is scissors. That's a tie. Scissors, rock smashes scissors, so computer wins. And scissors, paper, yep, there it is. And X to stop. Perfect. That's it. Very nice. That is perfect. Alright, so there you go. So now what we want to do is make it a game so that we can figure out who won and keep score, right? Okay, so let's do that. So what we're going to do is we're going to declare an RPS object and then send RPS the person moving the computer move, and then RPS can print out who the winner is. It's very simple. So RPS will have two instance fields, the person move and the computer move. It'll have two accessors, get person, get computer, and another accessor, who won. They'll print out actually that it is a tie or the computer wins, that kind of thing, right? Okay, so where are we going to, okay, let's declare an RPS object right at the beginning. RPS, I don't know, foo. There you go. Okay? And then, once we've got the move, so here's the move, right? Okay. So I'm gonna get rid of this for a minute. Okay, well, this is what I want to do. I want to print out. Alright, let's construct an RPS object. So foo equals new RPS, and let's say we input, I don't know, what are we inputting first? Person move, okay? So person move and computer move. And this will just compare things. So while loop is working, that's really what's new here. But let's finish the class. Okay, so there you go. And so instead of just printing out person move, I'm going to print out RPS.getPerson. RPS.getPerson, yeah. .getPerson. So this part should work the same, but now it's an accessor method. And RPS.getComputer method. And so we have our constructor, we have our accessor. Do we have this is an immutable class. There's no mutator, right? Okay, good. And then we'll print out who won. In fact, you know what? Let's just make that a two-string. So if we print out foo with a two-string, it'll print out it's a tie or computer wins or something, right? So let's print, okay, let's do another print line. System.out.println, and I'm just going to print out foo. There you go. So what does that mean? We have to make the constructor, the accessor, and the two-string. So we're going to overload the two-string that we inherit from the object class, right? Okay. Save that, and let's create a new file. Okay, so here's a new editor. I'm going to make this RPS.java, and your name, and the date. Okay, and why don't we save that? I'll save, Control S, RPS.java. Let's make sure we're in the right place. Okay, that looks like the right place. Let's make sure it shows up there. RPS tester.java and RPS.java. Perfect. Okay. Alright, so public class RPS. Alright, let's start with the constructor. Public or not, public. Void or not, neither. It's RPS. And what's the parameter of this? Well, string. Let's see, how do we write this? Okay, string person and string computer. Okay. String person for person move, and string computer for computer move. And so what do? Well, usually we do at least something like this.person stores person, the input parameter, and this.computer, the private instance field, stores the computer move. And so we need some private instance fields up here. Private string person, and private string computer. Okay, so there's a constructor. The first two accesses are easy. Get person is public. Public or not? Public. Void or not? String. Get person. No input parameters, just returns the private instance field person. Person. And the same thing for get computer. So public or not, public. Void or not, it's string. Get computer. No input parameters. Look at your tester. We didn't need any there. We needed two in the RPS constructor. Return computer. Okay, so now the two-string, public or not, public, void or not, string, two-string overload. Alrighty, and so what are we going to do with this two-string? Well, let's start with the tie. Alright, so two-string we usually have a temporary string, so not all our returns are stuck in an if statement, right? Return string. Let's make string temp just the empty string for now. Now let's get the tie part working. So if, when is it a tie? Person. Now remember, it's not equals because it's not a primitive method. The primitive variable like an int or a double, it's an object, right? So it's dot equals, these are strings, so you can use the dot equals method from the string class, equals computer. If that's the case, then we're going to make temp equal to, whoops, equal to, it's a tie. Okay, something like that, okay. Alright, so let's test this much. So if it's not a tie, it's not going to print out anything. The two strings are just going to be gobbledygook. It's going to be blank, right? Don't forget to return it. Return temp. And except for the Java doc, this is pretty much done. And except for the cases where the computer wins or the person wins, this is pretty much done. But there you go. Alright, save that and let's see how this behaves. Non-static method get person cannot be referenced. Why? Oh, RPS. Oh, it's not a static method. It's not RPS dot. It's foo dot. Ugh. So for 4647 in the tester, what happened there? Yeah, I meant foo dot. Foo. It's not a static method, right? Foo. Save. Okay. What else did we mess up? Nothing. Okay. So this should behave more or less like last time, and so it'll actually say when there's a tie. Okay, so I'm going to do rock. Was it a tie? And it is. I'm going to do rock. Was it a tie? No, so there's not, but there you go. And so let's stop it. Perfect. Okay, so let's take care of the other cases. Alright, so what happens if, let's say, it's not a tie, and the person plays rock? When does the person win? When it's computer scissors, right? Okay, so let's do that. If person dot equals rock, okay, and computer dot equals what did I say? Rock kills scissors, right? Scissors. If that's the case, then temp equals person wins. Let's see, the tie is 1. Okay, that's fine. Leave it like that. Okay. Then what? Well, now it's not an else, because else would mean that person dot equals rock and computer dot equals scissors is false, which by De Morgan's means person is not rock or computer is not scissors. So we don't need an else here. We need a separate if statement for rock paper, and paper covers rock, so that would be computer wins, right? So let's copy this. All right, but okay, so let's this is a tie. This is if person plays rock. Now, person plays rock and computer plays paper. Randomly chosen, then computer wins. And let's make that 3 exclamation points. Okay. Okay, I think that's it for rock. For if person does rock. All right. So okay, let's save that and see how that works. Let's do a Java C. Let's do a Java. Oh, this is getting a little slow. Okay, so let's do rock. Alright, so it's the time. Let's do rock again. And computer wins. Okay. Let's see if we can get a person wins. It's a tie. 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 Person wins. Rock, smash, scissors, perfect. By the way, if I do capital R, it still works, right? We didn't test that. Yep. We do capital P. Yep. We do capital S. Yep. We do capital X. Yep. Oh, this is working. I like it. Okay. Let's finish this up now. Let's do the case where the person plays paper. So it's basically the same structure here. Alright, so if the person plays paper, when does the person win? Paper, when paper covers rock, so when the computer plays rock. But if the person plays paper and the computer plays scissors, the computer wins. I think so. Okay. And let's do the third case after the tie, of course. And that's if the person does scissors. Now, when does the person win? When the computer does paper. When does the computer win? When the computer does rock. And that's all the cases. I think that's all the cases. Right, okay, so save that. And let's see how this works. Whoops. I didn't in Java see it. This is getting too slow for my keyboard. I don't know why it's so slow. So it's Java seeing RPS tester and RPS.java because they're both in the same folder, and RPS tester references RPS. Perfect. Alright, so let's see if I do rock. It's a tie. If I do rock, person wins. Rock and scissors. Yes. Okay, let's do paper. We didn't do paper. Paper. Tie. Paper. Person wins. Paper. Rock. Yes. Let's do scissors. Computer wins. That's true. Rock, smash, scissors, right? And more scissors. 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 Person wins. And more scissors. Is a tie. Perfect. Okay, I think we got it right. Alright, so let's just do X to get out. Okay. Now, how about keeping score? Now, the RPS class is done. I just want to keep score in the while loop. Keep track of how many times a person wins, right? So let's go over here. And let's say we have some kind of a counter. It's going to count whenever foo.toString is a P. Now remember, you don't have to write foo.toString when you're printlining foo, because printline and print automatically call toString. But if you're testing it in an if statement, you better call the toString method. Okay, so let's see. Let's add that right before we prompt the user for an exit. Okay, so let's do this. If foo.toString starts, now let's see, it's a tie, person wins, computer wins, starts with a capital P, right? If foo.toString let's see, the first letter, substring, let's see, 01, for the first letter, that equals a string capital P. Okay, then let's do person wins is a counter, person wins plus plus. Okay, otherwise num rounds automatically gets incremented no matter what, right? So let's say num rounds plus plus automatically. And then let's print system.out.println. Let's see, person, quote, person win ratio equals. Alright, so what's that going to be? It's going to be the person wins counter, over the num rounds counter. And then we figured out in class, these are both, I'm going to declare these both as ints. I didn't declare them yet before the loop, I suppose. And so let's make it so it's a double, so we get decimal results. And let's make it a percent times 100. And so let's add a little percent symbol. There you go, perfect. Okay, so what we need to do is to declare person wins and num rounds somewhere as an int and initialize them to 0. How about up here somewhere? Here, okay. So, I don't know, maybe here. So int person wins starts out at 0, and int num rounds starts out at 0 also. Whoops. And let's save that and see what we messed up now. Where'd it go? Semicolon, okay. Semicolon all the way down here. Good. Alright, let's run it and see if we can keep score now. Otherwise I think it's done, except for the Java doc. Alright, so rock. Okay, so rock person wins, so one person win over one num rounds is 1 over 1 is 100%, right? Okay, let's do rock. Person won again, 100%. Let's do rock. It's a tie. Okay, so the person won 2 out of 3 rounds. That's 66%. Nice. Let's do rock. It's a tie again, so he won 2 out of 4 rounds. That's right. Let's do rock. And 2 out of 5 rounds. And okay, the person won, so it's 3 out of 6 rounds. Okay, let's change it to paper. All right, so person won. What is that now? It was 3 out of 6, so 4 out of 7. 4/7. Is that right? Yeah, a little over. Yeah, that's right. Yeah, it's repeating this way. Yeah, okay. And how about scissors? Person wins again. So 5 out of 8. 5/8. 0.625. Yeah, that's right. And exit. Perfect. All right, let's just play around with some Java doc. All right. So we have the constructor. Let's start here. All right. So let's say this is a constructor. That's sufficient. And let's see, the constructor has, let's see, 2 at params. Okay, so at param, input parameter, person is RPRS. Okay, and when we pass it to the constructor, it's not going to be an X, right? Because it'll stop the loop before it does that if we hit X. At param, computer, same thing. Okay, so I like to say at param or precondition and at return or post condition. There's no at return, so post condition. Post condition is 1 round of the game is instantiated. And just simple. Keep it simple. Oops, and like that. Okay. Save it. That doesn't mess anything up, does it? Okay, that looks good. Okay. All right, and likewise, let's just copy this. Let's see what we're going to do here. Let's copy this here. Alright, so the get person is an accessor. There's no at param. There's a precondition. What's the precondition? Oh, I don't know. Person. Okay, person. The round has been instantiated, or person is this stuff, RPRS. And there's no post condition here. I'm not going to write a post condition because I have an at return. And at return, well, RPR, that's right, whatever person is. Okay. And perfect. Okay, now the rest are accessors, right? So let's just copy this and do the same thing here. It's an accessor. Precondition is the same thing. And at return, same thing. Okay, nice. And here, is this an accessor? Yeah. Now, precondition. Precondition is that person and computer are this. Okay, so I'm going to say, oh, this is computer, and I need that here. All right, and what does it return? It return. Oh, a computer. It returns who won. Or I could just say it's a tie, computer wins, person wins, right? So, I mean, that's going to take a lot of space. I'm not going to do, well, okay. I've returned this, or this, or, I guess it fits this. There you go. Just very simple with the Java doc, just keep it simple. And that's it. We're done. Okay, I think we're done. This is perfect. Okay, very nice. So there's your class, there's your tester. And we're using the new CS50 IDE. Very nice. And there's your shell. And there's your chapter 6. And C6X0, we're done. We're good. Okay, just checking that we got everything. And that's it. Hope that was helpful. Okay, bye-bye, YouTube.